It's broken!
Hole in oil pan. Oil all over the driveway. Honda oil pan was not available. Aftermarket oil pan available, but won't fit. Crank, but no start after oil pan installed. Oh my. The car fell onto the jack stand while trying to find a suitable spot to place it. Unfortunately, the 2x4 wooden block on the floor jack split and the car fell 1.5 inches. This video won't be a how-to video. There are many how-to videos online. Removing the old oil pan wasn't a problem. It's what comes after that. That turns out to be a major pain in the you-know-where. 2 sensors and an exhaust pipe that runs under the oil pan were all that's needed to be removed before the oil pan can be unbolted. In most cases, you might need a 14mm deep impact socket to remove the exhaust bolt. Assessing the damage. Not much to think about though. Needs new oil pan. Luckily, the jack stand didn't go through the pan. Otherwise, the oil pickup would have been damaged. Trial dry fit showed that the pan will not seat flush with the block. There were 2 areas that hit the windage tray and bolt heads on the block. You can see the scrape marks on the inside of the oil pan. This is the area of interferences. It is the side that goes against the bell housing. Comparing with the original Honda oil pan, this superimposed image shows the difference in the extra material around the bolt holes. Measuring with the calipers showed that there was a difference of about 1/10 of an inch extra material on the inside of the new pan. Marked off the area to be grounded down. After some time spent grinding down the area, multiple trial fits were needed before interference-free fit was obtained. Now that these were ground down and not hitting anything, the dowel pins were not going into the hole in the block. The pan needed to move towards the bell housing. This information becomes important later. There just wasn't any way the dowels were going in without damaging the dowels, gouging the aluminum block, or both. So, the only option was to remove them. I understand that some may cringe at the thought of doing such a thing, saying, dowel pins are there for a reason. I understand. Since these dowels were meant to be permanent, they were very difficult to remove. Punch and hammer wouldn't do it. No shoulder to grab. One came out after screwing in a bolt and pounding on it from the other side. As for the other one, I had to heat the aluminum with a torch to loosen it. I must have spent over an hour trying to figure out how to remove them. I really wanted to save these without damaging them. Oh well, I didn't have all day either. One of the sensors is the crank position sensor. Install it and plug the connector in. And the nightmare continues. After the oil pan was installed, the engine would not start. It'll crank and the engine tries to catch, but just wouldn't start. Since only the O2 sensor and the crank position sensor were removed, the logical choice was to remove the CPS and bench test it. Set up the crank position sensor on the bench to test the sensor independently from the system. The CPS uses Hall effect technology, and the way it works is, when metal is brought close the sense area, the tip in this case, the current is disrupted and voltage is affected. The normal state is high. When triggered, the signal goes low. It needs something metallic to come close to the CPS to trigger the unit. You can see the waveform on the scope in the back. When the CPS is triggered, there is a pulse that goes low. You can also see the green light turn on every time there is a trigger. Just from this, I'm confident that the trigger happens without glitching. The trigger light blinks consistently. Since the scope is very old and when time scale is set to show more pulses, it becomes blurry. This was the best I could capture with this scope. New oscilloscope. I put the sensor back in so I can take a better scope shot with a new cheap digital scope. When I cranked the engine, to my surprise, the engine started up, but barely. It would barely idle, and no more. But luckily, I was able to take a full engine cycle worth of waveform. It also gave me a good feeling that I was close and reinforced the idea that the alignment was the issue. Simply by disturbing the mounting of the sensor was enough to allow the sensor to start responding, even if sporadically. What I saw in the waveform was that there were pulses missing in the middle. The spaces at the arrows are markers, 2 blank pulses, and are supposed to be blank. There's supposed to be 60 pulses total, including the 2 blank pulses. Those missing pulses would be sure to confuse the computer determining the timing. If the sensor is working fine, I can be certain that the issue is with the alignment due to the oil pan. The new scope shot reinforced the alignment theory. I made a 3D print of a mock-up of the CPS unit with the correct dimensions. I also added a hole through the middle so I can see the alignment. There may be a possibility that a 3D printing is not a precision process, but it can give me an idea on what alignment problems it has. It's clear that the reluctor tooth is offset. The front of the engine is to the right. It was mentioned earlier that in order for the dowel pins to go into the block, the pan needed to move back towards the bell housing. Well, the pan now needs to go forward for the sensor to align properly. Now, the dowel pins would not fit for sure. The red lines represent the reluctor. Honda calls it crank pulsar plate. The shape of the tooth is square, so the sensor needs to move half of tooth to the right. Thus, the pan needs to move to the right or towards the crank pulley. Instead of moving the oil pan, I decided to move the sensor. It turned out that the sensor is in the bore loosely. I was able to place a piece of wire under the flange on one side and another wire under the bolt head on the opposite side of the bolt hole. This effectively cocked the sensor just enough for the proper alignment. Start the engine. With the awesome modification to the crankshaft position sensor, I jumped into the car and hit the start button. It started right up, as if nothing ever happened. The car was saying, "Yo, what up? Were you having problems, oh summon?" Hooked up the scope again to look at the waveform and make sure it looks clean. "60 pulses with 2 blank pulses. Well, ain't that a beautiful sight?" You can clearly see the blank spaces for every engine cycle. You should be able to see if there were any missing pulses. Nope, just the 2 blanks only. In conclusion, don't use aftermarket oil pan for Honda Odyssey with CPS in the oil pan. The machining tolerance was off just enough to get a hit or miss situation with the sensor. There was another video with a Honda Odyssey experiencing the same issue in a same scenario where the owner replaced the oil pan and the engine would not start afterwards. The mechanic replaced the CPS, but did not fix the issue. They took it to another mechanic, and after pulling his hair out, he replaced the sensor also for the second time. But this time, for him, it started up. My guess is that none of the sensors were bad at all. It was just that the alignment was so iffy that when he disturbed it, it was nudged just enough to catch and trigger the sensor. I highly suspect this because the pan they used was the exact same aftermarket pan that I used as well.